What we're going to do today is we're going to teach you three different methods of making sketches. And unless we've got, how many engineers we got in here? None of your sketches will probably look like that at the end of the day, but it would be nice, but they won't. Okay. Like I said, we're going to teach you three methods: transecting baseline method, triangulation method, and the azimuth wheel or the compass rose wheel, however it's called. And we'll show you the applications of when and how to use these. Now, on some scenes, we may use one method. We may incorporate two methods. We could use all three on some scenes, and we'll talk about that. But we talked about the importance of the sketch, how it complements the photographs, and the photographs in the sketch will complement your written narrative or your testimony. Again, think of the jury. Every time I'm at a crime scene, I've spent enough time testifying on the stand, I think, okay, what am I looking at when I get in the court? What looks best for them? What's going to work best for me? That is an acceptable sketch, okay? It's a rough outline. Pretty rough. You don't have to be an artiste to do this. All you're trying to do is make the point come across. One of the things we're not going to try to do is clutter up our sketches, and I'll show you how to get away from that. Some of the equipment that we're going to use, we'll have templates. I've always found that a mechanical pencil works a lot better. You try to keep it as neat as possible, and you got to have an eraser because you're going to make mistakes. GPS, we'll talk a little bit about that. That's still acceptable, but it's not an exact thing yet. Your kits that you're going to get will have a couple tapes in them, a couple of these tape measures. This is the compass rose. I don't know if you can see it from back there, but it goes from 0 all the way around to 360 degrees. We'll talk about that. This is what they call a disto. This is real nice if you're forced to do a sketch by yourself. If I take a disto and I put it against the floor here, shoot the laser across to the other wall, it gives me a very accurate measurement, as long as there's nothing in the way. So you can do it one-handed. I remember I was measuring my house for furniture or something one time while I was on the phone using the disto to measure out the rooms and stuff like that. So a lot of the teams will have them out there. Your kits will also have a compass in there. Remember, they're not real accurate when you're on metal, even on concrete. Remember, there's rebar usually in the concrete and stuff like that, and it could throw your instrument off. And then I'll spend a little bit of time and explain to you the total station. This is the Nikon total station that's out there in 18 of the field offices. When we prepare to do the sketch, we're going to go, the team leader is going to do the walkthrough, you're going to get the briefing. Like I said, if I'm going in and they're going to want a sketch of a house that I searched, I can stay out in the street and do the outline of the house. One of the things is you want to draw your rough sketch as big as the paper that you have. Okay, maybe it's a small house. Use up all your paper. It gives you more room to put things inside, not clutter up your sketch. I've seen a lot of people have this big sheet of paper and their sketches up here in the corner, and you got to have a magnifying glass to figure out what's in it. So take all that. We're going to take overall. We'll start with overall. If we're doing, say, this room, I would sit there and I'd draw basically a square, and I'd show the wall coming out here for the door. And then when I began the search, I would take overall measurements. I would put the windows in roughly where it looks like, and then I would add the measurements to it. Same thing with the doorway. Most of your doors are standard. You're going to find that most of them are of the same width until you get into commercial buildings. When we draw a door in a sketch, we want to show which way it opens up. Most of your homes will open in. Most of your trailer parks, the doors will open out. That's something that's good to know, especially if you're trying to breach the door, you're on SWAT or something like that, what type of tools you're going to need and stuff. Then, after a discussion with the team leader and other agents involved or other ERT people involved, you're going to want to look and determine what fixed objects are important. Which rooms in the house are important? Maybe some of the rooms had no play in it. You know, if I went to a homicide scene and the guy came through the sliding glass door in the bedroom, came in, killed somebody on the bed, and went out the same door, I would show the house, but I wouldn't do the detail for the other rooms if that wasn't involved. I'd get very detailed in the bedroom. I'd show the doors for the whole house and everything, but as far as furniture and items of evidence and stuff like that, I would save for the rooms where the activity took place. You're not going to know this sometimes. You're going to have to do more, but when you do know that, you can put that in. Determine the fixed objects that will be used in the sketch. You know, we're talking about furniture, things of that nature. When I label things, again, items of evidence get numbers. Okay, that number is the same number that's going to be on the log where it's collected. You're going to hear this over and over again, and eventually it'll sink in. Fixed items, I'm going to give letter characters to, so there's no misunderstanding of what's going on. And then, again, based on the scene, you got to determine which of the three methods that you want to use, or what combination of the three methods that you want to use. You're going to record some administrative information in the legend, and these two things right here, where is north on your sketch? Doesn't have to be going straight up. North could be here, north could be at an angle, but it's got to be on there and not to scale. Okay, so compass orientation and disclaimer, not to scale. Two very important things. Two very important things. It'd be really important a week from Friday. Again, I showed you this earlier, the diagram sketch that's in your packet. I would fill this out because it's got the checklist for you, and then I would put everything on the graph paper that'll be in your kits. But the main thing that we want on there is the location, just like everything else, the date, case identifier, who actually prepared the sketch, who's the assistant, and again, not to scale, and where is north on your sketch. Not to scale, and where is north on your sketch. This is one of my better sketches here. I did this school for a police department, actually Flint, Michigan Police Department, and I broke everybody into groups of twos, and we went through the building. And two of the sergeants, I put them together because I figured everybody was patrol officers and two sergeants. So I figured if I put two sergeants together, at least one of them's got to do some work. So, but what I didn't know is they both had contracting companies on the side and had engineering backgrounds. So they went out, did their sketches, turned them in, went to lunch. I stayed there and I'm reviewing, and it looked like a blueprint from these two sergeants. So what I did is I did that and put their names on there. And then what we did is we showed all the sketches after, you know. So I thought, well, here's the one, I saved the best one for last, the two sergeants, and throw one down like that. Everybody started laughing, except for the two sergeants. They didn't think it was very funny. And I never did show the rest of the class their work. Okay, again, three methods we're going to look at: triangulation, baseline or transecting baseline, and the azimuth wheel or the compass rose. Triangulation. Very easy concept. Find at least two immovable fixed reference points. Examples here: corners. They could be inside corners, they could be outside corners. Fence posts, something that's permanent there. Telephone poles. If you select a telephone pole to use as a fixed point, take the data off the telephone pole if it's on there. Most of them will have data. Just make a note of that in your notes. Okay, and we're going to label the points A, B, C, or D, or RP1, RP2, RP being reference point. And we can number them then, as long as we got the RP in front of it. And all we're going to do is take our two fixed points, and let's pick two in this room. We'll do the nearest inside corner. Okay, this would be one of our fixed points, and we'll have the same thing down there. And if I want to measure the podium, I'm going to take two measurements. One from that corner to this corner, one from that inside corner to this corner. So now I know where the corner of this podium is. okay? It can't be anywhere else in the room. If this is 32 feet 6 inches and that's 14 feet 4 inches, there's only one place in the room when I pull those two tapes out at that distance from those corners where it'll converge, and that'll be right here in this corner. Okay, does that make sense? That's triangulation. Now, what issue do I have at that point?
Things being in the way of the measurement.
Well, that's a problem.
Which way is it facing?
Yeah, right. Now this thing, I could pivot this thing 360 degrees. I know where this corner is, but where's the rest of it? So what am I going to do? I'm going to take the same two measurements to this corner. Okay, so I'll know the measurements to this corner and this corner. That way I can place this. If I have two of the four corners, I can lock this in the sketch. If I only have one corner, I know where this is, but you could spin this thing 360 degrees. The corner would always be there, I'd be correct, but I wouldn't know where. So if I do this second corner off of that using triangulation, I'll be there. Now, one of the issues we run into is things getting in the way. Just remember this. When you're doing a measurement and you're running the tape, it's got to be level to the ground and it's got to be tight. Okay? So, if I'm sketching this room, I'm going to have two people helping me. Okay? I'm going to give them the tape and I'm going to direct them as to what measurements I want. I'm not going to let them decide, because I'm the one doing the sketch, my name's going to be on it. And I'm going to tell them, okay, from this corner here, I need a measurement to that inside corner and to that inside corner. And I'll go ahead, and what I would do is I would call, this is a fixed item. First of all, I'd mark the four corners. They'd be A, B, C, and D on my sketch. Then I would put the podium in the sketch, and I might give this E and F. So then what I'm going to have is, if this is F, or E, let's say this is E, I'm going to show off the page on a chart the measurement from A to E is this many feet. The measurement from B to E is this many feet. Then I'm going to go to this corner F, and I'm going to go from A to F is this many feet, and from B to F is this many feet. But I'm going to direct those two helping me to do it. And I want them to give me the information consistently. When we look at a tape measure, when we look at a normal tape measure, not an engineering tape, 12 inches equals a foot. If you look at this table, at this here, I pull this out and I go up to, let's say, 40 inches. Okay, 40 inches is 3'4". That's my preference. I want it how many feet, how many inches. I don't want 40 inches because at some point in time, I'm going to have to do that math and divide everything by 12. Okay, and it's just time consuming. So that's the way I want it. And what will happen is, when you have people doing the measurements for you, they're going to get real comfortable. They're going to take off and they're going to start going fast. You're going to have to tell them, stop, let me catch up. And they're also going to start giving you 3'4", 3'4", and then all of a sudden 40 inches. You know, wait a minute, look at the tape again, give it to me. I don't want to do the math. You know, it's just time consuming. But you're going to laugh when you're out there because somebody's going to start taking off on you. And you got to slow them down. So that's basically triangulation if I got two fixed points. Okay? If we're outside and the bleachers that were out there on the soccer field, you know, those are solid corners on that. So what I would do is, if I had evidence near that, I would draw in the bleachers, all that stuff. I'd label that accordingly. I'd make the different corners. I'd give them a alpha character, and then take my measurements off of that, and I'll show you how that works. Here we have an area. This square here is a fixed immovable object. It doesn't matter what it is. So they've gone ahead and they've called everything A, B, C, D. They've marked each of the four corners. Now we've got a bomb, we've got a set of handcuffs, and we have a key. So what we've done over there is set the columns up for item numbers, and then we know we're going to be taking measurements off of A, B, C, D, so we go ahead and set that up. Item number 1 is the key. We know the key from A to the key, this line here is 12 foot 6 inches. and we know that from the key to line B is 7'3". Okay, we go off the other side on item number 2, the handcuffs, and we know from B to 2 is 10'4", and from C to 2 is 6'1". And same thing with the bomb here. It's that easy. Okay, now this is either on one page of your sketch or 3/4 of it, and this legend is over off to the side or on the next page. Now the thing about this is, you know, you could do this all day long if you had a bunch of evidence here and stuff like that. Special Projects Unit is a unit back at the laboratory. They are the ones, when you go to court and you see this beautiful finished product, and we'll get into some of the stuff they're doing back there now though, is you can take your sketch that you take at the field, as long as you've got all the measurements, and you can send it back to them and say, hey, I need a completed sketch for court purposes, and they will sit down and they'll do a real nice sketch for you. There'll be some examples into it. Here's a little bit more involved. Same concept though. We've got 14 items of evidence in this room, scattered all over the place. They've gone ahead and made reference points 1 through 4. Then they added another column, which is the Z. You know, you have the X, the Y, and then Z is elevation. When you're talking this, Z is the elevation. So if we look at item number 1, which is the green coveralls, which I found earlier. Okay, right down here. They're on, what letter does this have? S. Wait, what is it? Oh, it's the desk. So we got item number 1 sitting on the desk. So if we look at that, they went off of reference point number 1, and it's 16.4, and then they went to reference point number 4. 2 fixed points. They did it 9'2", and we know the Z coordinate, it means it's 3 feet off the floor on top of the desk. Same throughout. So you can see in this legend here how they set it up as far as the evidence, and then as far as the fixed items. They've identified what the 6 items. Now you look at the sketch and you can see everything roughly where it is, and it's not real confusing. One of the things they did is they did overall measurements here. You got a 3-foot, 5-inch door, I think this is what it is. That wall is 17 feet, 2 inches, and stuff like that. One of the things when people start putting measurements in is they start turning the paper around. You know, so you got stuff upside down, right side up. Always try to write everything the way they look at it and stuff. But you could take this rough sketch and send it in the Special Projects Unit, and again, tell them you need something for court purposes, and they'll give you a finished product. Here's another one. Here's another situation. This is a post-blast situation over in Beirut. I went over on one of the same situations. Had a car sitting up at the curb. Driver went in, turned the keys on, and that was the last time he ever turned a set of keys on in a car. We had stuff splattered on the wall. We had debris all over the place. Interesting thing though is when they told us, get ready, you know, we all go off of CNN. You know, you look at CNN and boom, hey, we got a bombing over in Beirut. Are they going to call and ask for assistance? So everything was working. They're asking for assistance. We're getting country clearance, doing all that stuff. Well, in the meantime, I'm watching CNN, and I see this street here is probably about 1 city block, maybe 200 to 300 people all around the vehicle and stuff like that. So I knew going in that we were going to have a contaminated scene and stuff. But the basic, what we did is we went over there on a post-blast, and Barry will talk about this with you next week. The crater is crucial. You know, they can do the math on the crater from your measurements and figure out, based on what the crater is made of, if it's asphalt or if it's concrete, what likely type of mixture was used, or what kind of component was used to cause that size of crater and that type of material. So the crater is very important. Positioning of the vehicle in this case was important, and position of all the other vehicles that were parked on the street, tied into an intersection and things like that. So let's see what he's done here. He's got, this is Tim Duran's sketch, also in our unit. He's got reference points 1 through 4, and he's got those set up. at different points, probably light posts on there near the intersection, and all he's done is triangulated each piece into that. And again, this is something else, and this is what I did when I was over there in Beirut. Came back with something similar to this, gave it to Special Projects Unit. They put together a nice finished product. So that's triangulation. That's one of the basic ones. Now, where is triangulation work? Well, if you're inside, you've got a lot of reference points, a lot of fixed points. Okay, if you're in an open field, there's nothing out there. Okay, there's nothing to reference your, no reference points to establish out there. So it wouldn't work good in that situation. It works good in an indoor scene. It works good adjacent to a building or something like that, where you've got fixed points to measure off of. Any questions on triangulation? 2 fixed points to the item of evidence. Go ahead.
You say 2 fixed points to the item of evidence. On the coveralls, it looks like they went like center mass of the item. But
Right.
What if you had like a weapon or something? Would you want to measure?
It would depend on the, if the positioning of the weapon was important, then yeah, I would triangulate both ends of the barrel, and I would probably triangulate the end of the butt of the grip. That way I know exactly where it was sitting there. Okay. And then the other thing is you can take overall measurements of the weapon, or if you're taking a photo with the scale, they'll have that, and then they can just plug that right into where it should be.
Otherwise, you use center mass. Is that right? Like if you're doing like this book,
Yeah.
would you go center mass?
Yeah, I would probably go center mass on it if the positioning of the book didn't matter. Okay. The other thing, but if it was something important, and I'm going to have the overall measurements of it anyways, it's rectangular in shape, so I could do 2 corners of the book and put it in there. Now, when we have a body in the scene, we try to measure to all the joints. Okay, because I've never been to a homicide where the body is like this. I mean, they're like this, they're like this, they're everywhere. They're all twisted up. So I'm going to measure to all the different joints. I'm going to take one to the top of the head. I'm going to do the shoulders, do the hips, knees, ankles, and stuff like that. That way, it's looking like a twisted mess, but as long as you have the measurements, and once it gets up to the morgue, they're going to tell you how tall or how short that individual was. That they can put all this stuff into a CAD system and come out with the body in the position it was in. Okay, we'll move on to transecting baseline. Transecting baseline is another effective method. It can be used indoors if you've got, again, room to move everything, to run your tapes and everything like that. And basically what you're going to do is, here we're talking about the X axis, the Y, and then the Z, the elevation. So we're going to lay a tape in the best location for a scene. If I'm doing this hallway, I'm going to lay the tape probably from the inside of this door frame all the way down the hall. I know where I have a starting point, and I'm going to make sure it's parallel to the wall on this side. If I was running it in this room, I may run it right along the wall. Run it right along the wall. And we'll show you some examples of that. And all we're doing is, we have a starting point for the tape, which is the datum point where it starts. And if we measure that wall out, it might be 26 feet, 17 inches, or 11 inches, 1711. And all I'm doing now is I'm coming out, and if I've got a piece of evidence here, I'm going to take another tape. And I'm going to run it from that point at a 90-degree angle to my item of evidence. So I'm going to put down 2 measurements. How far up the tape it was, my starting point here. Let's say it's 3'6", and I'm another 9 feet 10 out, okay, to the positive side of the axis. And that's all I'm going to do it. Now, getting the 90 degrees is important, because if it's at 90 degrees, then it's going to be accurate. So how do we do that? We can either do that with a square, you know, the measuring squares that the carpenters use, or we can run what I call the dumb end of the tape, the beginning of the tape to the item of evidence, walk the tape over to our line going here, and if I rotate, pivot the tape back and forth here, the shortest distance over there is going to ensure 90 degrees. Okay, so I have get a dark enough color here. If I run my baseline here, and this is 0, and this is 15 feet 4 inches, and I've got an item of evidence over here, I want to know how far down the tape it is and how far over. So what I'm going to do is I'm going to take the beginning of the tape measure, when I pull it out, the dumb end, and I'm going to run it over here. And I want that measurement, but I have to have that at 90 degrees. So what I'm going to do is I'm going to take my tape and I'm going to move it back and forth, pulling it tight, till I get to here, the shortest measurement. Let's say this is 10 foot 1. So if I get it over here, it's 10 foot 3. If I get it over here, it's 10 foot 3, 10 foot 2, 10 foot 2, boom, 10 foot 1. That's the shortest distance. That will ensure me 90 degrees. I know I got a good 90 degree angle coming over, and I know it's accurate then. And again, not to scale, approximate. But that's going to be pretty darn close to what you need. So that's the baseline method. Again, you lay one down, that's your X axis, and then you get the other tape out, and that's your Y coming off of it. You can use a protractor, or you can use a square like the carpenters use to ensure it, or you can do that pivoting method to get the shortest distance. And we'll show you all this when we go outside. But on your sketch, you want to indicate where 0 is, where you're starting your tape and where it's running to. Here's a good example right here. What we got is 0 here. We're running this right through this room, 0 all the way down. We have item number 1. We come off the tape at a 90 degree angle. We know that up the X, it's 5 foot 6, and over to the Y, it's the right side's minus, left side's positive. It's a minus 4 foot 2. That way we know which side this item of evidence is on. Same thing with item number 2 down here, the syringe or screwdriver, whatever it is. We know that it's down the baseline, it's 10 foot 4, and to the positive side, it's 5 foot 9 away from there. It's that easy. Any questions on transecting baseline?
Is this baseline dead center?
Well, what you have to do is, we measure evidence in the event we ever have to go back and recreate the scene for a jury and stuff like that. That has happened to me one time in my career, but it does happen. So if I'm going to go ahead and set up my baseline, and we have a rectangular room like we do here, what I'm going to do is, if I've got, say, matching doors on both ends or matching windows, I'll run it off of one of the corners and run it to the opposite matching corner. If I don't, and I'm just running it down the middle of the room, then in my notes I'll make a measurement of how far down this wall and how far down this wall. So if I ever had to go back out there, I could start my datum or my 0 point at the same location, and I know I run it. And this has to be parallel. So if I'm 4 feet from this wall, I want to be 4 feet down here also. And I'll set that up. And what a lot of times we'll do is we'll run the tape, we'll lock the tape out, and then we'll tape it down. You know, put some tape down so it doesn't get kicked around, moved around out there, and we'll go ahead and we'll measure off of that. Does that answer your question?
Yeah, but if you have a door, like where the 0 is in it,
Yeah.
on the other, then you still have to figure out how far that was.
Yeah, but if I had matching doors, and we used to do this at the cabins up there in Prince William Park, and they had matching doors on both sides, so it was always easy. You go to the inside corner of this door and run it across to that one. And we knew that, you know, this was 4 feet and this was 4 feet, you know. Yeah, you have to know that, though. You have to check that out. On the other hand, if I ran this against the wall, right along the wall, then that wouldn't be a problem either. But I may have an obstruction that I can't, that I have to run it down the middle of the room or something like that.
So like in here, if you were to go down the middle of this room,
Yes.
then you would measure from that wall to,
No, what I would probably, yeah, because that's a consistent wall. Okay, so I got 15 feet 4 here is where I'm starting it from that wall. I'm running the tape this way, and I'll go down to that corner and run it out 15 feet 4. That way I know if I have to come back, I go to 15.4, start running my tape, double check it down there, and I've established the same baseline. Then I come back and I can place item number 1 because I know if I come 5'6" down and 4'2" to the right, that's where my evidence is right there. That's where it was. Now, you can see different applications. Here's at the top, we're looking at a hallway, probably like in an office building. You got all these offices off of that. You might want to run one right down the hall. It works very well. Here's a shot-up vehicle, bullet, and you run a baseline along the bottom, and you measure up to each of your points. I had that shooting you saw earlier was December 18th, I think, 1988. 7 days before that, to the week, there was another agent-involved shooting when I was out in Phoenix. And they were trying to arrest a fugitive out of a car. One of the agents came into the passenger window. The guy then puts it in reverse, and they get struggling, and the agent's gun falls on the floor. And the car's now moving. The other agent's standing there covering his partner with a gun, can't do anything. So he goes, takes cover. The other agent bails out of the car, gets his gun after he runs a pencil in the guy's eye, and grabs his gun, and they bail out. Now we got this car sitting in the middle of the intersection. For some reason, what was that? For some reason, the agent on this side of the street took shots at the guy, took 5 shots. He had a Model 60, the old revolver, the 2-inch barrel. And in Phoenix, most of the streets go down like this, and when it rains, everything runs down the middle of the street. He was on this side of the road. The houses were elevated. He flew 5 shots right across the top of the vehicle. Right across the top of the vehicle, went right into a garage door. Had a pretty nice pattern in this garage door. So what I did is I ran a baseline at the base of the garage door and just measured how far over, and I keep hitting the wrong button, how far over and how far up each of the bullets were, and put them in there. But this is a, you know, shooting of a vehicle. It's the same principle. So it can be used on a horizontal basis or on a vertical like that. Okay, this looks like a military base to me. And basically we got items of evidence along the road here. Good place to run a baseline. You know, you'll read some literature where they say set your baseline up facing north. Well, that doesn't always work. Some people try to do it. It doesn't make any sense. I would use the natural roadway here. And again, we're going to start a datum point. Maybe if this is a sewer drain at the center of that, I'm going to make a note of that. It's going to be on this shoulder of the road, and we're going to run it all the way up the base, and we're just going to measure over to each item of evidence. So how far up it is from the starting point, and at a 90 degree, how far over. And that's basically what they did this. And this is Fort Gordon in Georgia. It did look like a base. And you could see, damn it, you could see here the road, all the item of evidence, and again, item number 1, 152 feet 10 inches. They must have started their datum down here possibly, and then the Y is 19 feet. It was 19 feet 11 inches off the road, all the way down through their evidence. Any questions on that? Again, we're going to create this, our own baseline. It's not a natural thing. We're going to come in and create it ourselves, document how to set it up, and then take our measurements off of that. That, again, works. We saw it on a vertical surface. I talked about the garage door, the vehicle, hallway of a large building, sometimes down a room, stuff like that. The other thing is we can always create our own starting points. And when we create our own starting points, what we do if we're in the middle of nowhere and there's no reference points or anything like that, is we can run rebar, pieces of rebar into the ground. And if we run rebar into the ground, we usually pick 3 pieces of rebar and we run them so we end up with this kind of cone shape here at the top. We'll run 3 on angles. You end up with this round area, and your starting point is in there. And the reason we run 3 bars on angles like that is because you may have to go out there a year later or so and find these things, and the best way to do it is with your metal detector. You're going to have a rough idea where it is. You can go ahead and take a GPS of where it is. They're not going to be real accurate, but they're going to get you in the ballpark of where you are. And then you can come in with a metal detector and it's going to hit that rebar. The metal detector shoots an opposite cone, you know what I mean? So it's going to pick up these 3 pieces of rebar. You'll find them and then go ahead, set up your points again. And if you're setting up a baseline, what you'll do is you'll put rebar at both ends. Find both ends, run your tape, and then redo your measurements and be able to go back over what you had. The next one, and this one is really easy, is the azimuth wheel, or the compass rose, azimuth circle. You'll hear it referred to as that. I have one right here. All the teams were given several of these, okay? Some of the teams may have to go looking for it, but they're out there. But again, basically all we have here is a wheel. It's got a handle to carry it. It's got a hole in the middle, and it goes from 0 all the way around to 360 degrees. What we're going to do is, and this works real good in a real open area, a post blast, or it'll work real well at like a plane crash or something like that. We're going to pick a place, try to get it maybe in the center of all of our evidence, and we're going to set this down. And then we're going to get, and you'll have it in your bag as a compass, and we're going to find north, and we're going to set 0 to north, okay? Always set 0 to north on this, okay? And then what we'll do is, normally we'll have small nails, and we'll put them in these opposite corners. This thing is now locked in. It's in the middle of our field, it's facing north, and then what we're going to do is we're going to triangulate this board in, okay? We may have to run, 100 and some feet to the next point, but we're going to triangulate this in. So we're going to use 2 methods when we use this. We'll find 2 fixed points out there. We'll run measurements to this corner off the 2 fixed points, and then we'll run measurements to this corner also off of 2 fixed points, just to be safe. If we know it's at north and we know where this corner is, we can always pivot it and point it to north and lock it in. But I always do the 2 corners on there. And then all we're going to do, all we're going to get with this is angle and distance. So we're going to start the dumb end of the tape here. We'll have a nail here, a larger nail in the middle, hook our tape into it, and walk it out to our item of evidence. Pull it tight, and you're going to call out the measurement, 142 feet, 4 inches. Then who's ever at the board is going to look at the angle on the board. Now, what we run into, one of the problems is, if I'm running this tape from the center out, I'm covering 5 degrees on this board just with the width of the tape. Now, 5 degrees in a short distance isn't that much, but the further you go out, the more exaggerated 5 degrees gets. So what I always do is I always measure off, you should measure off of one side or the other. So if I'm lined up here, I always use the top of the tape so I'm consistent, so I know I'm at 150 degrees. But if I look at the bottom, I'm at 157 degrees or 156 degrees. So I always go off the top because that can mess you up in here. always go off the top, and I'm at 150 degrees. So I'm only going to record 2 items of information. One is the angle, what degree it's at, and the distance. And the other thing is, once we set this up, you want to cover and make sure you get all your evidence. So some people start at 0 and work their way around just to make sure that they don't miss anything. Again, this is what I talked to you about. Place the wheel in the center of the evidence field, secure it with the nails, point the 0 to north, and then mark exact location of the wheel with either triangulation or using the GPS and rebar system. So we got 2 items of evidence here. Number 1 being the dynamite. Dynamite, we know it's at 41 degrees. As long as this is lined up north, it's at 41 degrees and it's 15 feet out. This device here, item number 2, is over here at 267 degrees and it's 12 feet out. Okay, it's that simple. It's that simple. And like I said, we'll be out there doing all this with you. Measurements, they must be accurate within reason. 1/4 inch is adequate for our purposes if we take everything to the 1/4 inch. Now, if you get into something critical, if you've got some type of device or something really important, or say a weapon close to a body, something like that, have 2 people check it. And when someone is doing the measurements for you, they holler 14 feet 5 inches, repeat it back to them. 14.5, is that correct? Boom, and go. Keep an anchor on them because they're going to have a tendency to start getting comfortable and taking off on you. And you're the one that's recording all this data. Don't try to remember numbers. As soon as you get them, write them down. If you can't, tell them to repeat it because you're never going to remember them accurately. Yeah, again, always use the same side of the tape. I'm always top. I always go off the top of the tape. Okay? The tape is this way, here's the top. If the tape is this way, this is the top, on top of the numbers. I'm always very consistent with that. And again, you don't have to draw any measurement lines on the diagram itself. If we go back and use this type of legend set up for our item numbers, and with the azimuth, we have degrees and feet. With triangulation, we're going to have reference points and set up a little chart just like that. Okay, here's a case where they have an azimuth board out there. Looks like we got a body and several items of evidence that were flagged. This is it. Here's your azimuth board. Here's your body. That's all it took. But item number 1 is 7 feet 8 inches, 235 degrees. It's a lens. Item 2, 6 foot 7, 311 degrees, a beige button, and all the way down. It makes it that easy. Again, what we have here, we look at it. Number 1, we've got north, the direction. We've got not to scale. And item number 1, distance in degrees. And then they're showing here in the corner the triangulation for the, I believe that what they're doing here is A, B. A is a base of a power pole. B is the guide wire. And reference point, point of origin, PO number 1 and PO number 2, showing the way the line ran. PO 1 and PO 2. So the line started here, and this is a baseline that they put in place, and they're showing it how they did it there also. We've seen these 2 sketches before. Again, we want to get away from some of these lines, and we could do that with the legend that we talked about. Now, case example here. This is Columbine High School. Denver ERT went out there, and we also sent a team out from Special Projects Unit. Special Projects Unit is set up They do multiple things back there, but one of the things they have is they have a couple engineers back there that are working the computer assisted drafting system, the CAD systems. They're very familiar with that. They also have the artists back there that do the facial reconstructions. We'll talk about that later this week. But here's Columbine High School. And you show ERT out there, and basically they're identifying possible items of evidence, and what they're doing is they're putting markers or flags in where all the evidence is. Now, they used the Nikon Total Station there, and they did the exterior of the building. And I'll tell you a little bit about the Nikon Total Station in a little bit. But they also ran a baseline right down that sidewalk and then measured both sides of the sidewalk, all the items that were entered in there. Triangulation was also used at this scene. And again, item of evidence out here going off of 2 fixed corners. And this is basically what they were looking at when they went in there. This is the cafeteria. These were the unexploded tanks that, thank God, didn't go off. But they went through, and you could see all the backpacks on the floor. You know, after the students were either evacuated or were carried out of there, all the backpacks were laid around, left around, and they kind of used that to position some of the students where they were in the cafeteria when it happened. Cafeteria and the library were two of the biggest areas hit. So, any questions